Section 11, question 1. Find the integral of 1 over 3x to the power 4, and there's 4 options. So I'm going to first of all prepare to integrate by bringing the variable up and using my rules of indices. That will be 1/3 x to the minus 4. So remember, for integration, add 1 to the power, divide by new power, so it's 1/3 x to the minus 3 divided by my new power, which is minus 3 plus c. So I've got a third divided by minus 3, so I'll put the minus at the side. A third divided by 3 is a ninth, so it's now 1/9 x to the minus 3 plus c. I can then bring the x to the minus 3 back down, and that's 1 over 9x cubed plus c. And that's option A. Section 11, question 2. Integrate 1 over 6x squared with 4 options. So I'm going to first of all prepare by bringing the x squared up, and that will be x to the minus 2. So add 1 onto the power and divide by my new power, so that's going to be 1/6 x to the minus 1 divided by minus 1 plus c. So 1/6 divided by 1 is 1/6, 1/6 divided by minus 1 is minus 1/6 x to the minus 1 plus c, and that is option D. Section 11, question 3. Integrate the cube root x minus 1 over the square root x. So I'm going to first of all prepare to integrate by bringing variables up from the bottom and getting rid of the root sign. So the cube root x can be written as x to the 1/3. Remember that square root x is x to the half, so I'm just going to do two things at once there. Change that to x to the half and then bring it up to prepare to integrate. And then I'm going to integrate by add on 1 to my power and divide by my new power. So 1/3 plus 1 is 1/3 plus 3/3, that's 4/3. So x to the 4/3 divided by 4/3. Add 1 to my power, minus a half plus 1 is minus a half plus 2/2, that's 1/2. So x to the half divided by my new power, which is 1/2. Remember, it's an indefinite integral, there's no limits, therefore I put on my constant of integration. I'm dividing by a fraction here, so we're going to flip over and multiply, so that's 3/4 x to the power 4 over 3. I'm dividing by a half, so bring that up, multiply, flip it over, so that'll be 2 over 1, which is 2, so that's minus 2x to the half plus c. That's the final answer. Section 11, question 4. Integrate 2x minus 1 all to the power 1/2. So I'm integrating a bracket here, so add 1 on my power and divide by my new power, multiplied by the value in front of x, which as you can see is 2. So 1 on my power is 1/2 plus 2/2, that's 3/2. I then divide that by my new power, 3/2, multiplied by the value in front of x, which is 2, and add on my constant integration. These two can cancel out, which will leave me with 1/3 bracket 2x minus 1 all to the power 3 over 2 plus the constant integration. The correct answer is option A. Section 11, question 5. Find the integral between 1 and 0 of cos 3x minus sine 1/3 x plus 1, correct 3 decimal places. This is fairly straightforward. I'm going to use my formula sheet here to take me forward with the integration. There's going to be no constants integration since there's limits and it's a definite integral. So as we can see, cos ax becomes 1 over a sin ax when you integrate it. So cos 3x will become 1/3 sin 3x. I'm now going to integrate the sine element of the function. So sin ax becomes minus 1 over a cos ax. So if it's a minus, that will then become a plus. So plus 1 over 1/3 cos 1/3 x plus 1. And that's between 1 and 0. So I'm just going to tie this up. 1/3 sin 3x. 1 divided by a third. Well, that's 1 times 3 over 1, that's 3. So that's plus 3 cos 1/3 x plus 1, close the bracket, between 1 and 0. These questions are always in radians, so I'll just make that substitution. So 1 over 3 sine 3 lots of 1 plus 3 cos 1/3 of 1 plus 1, close the bracket, minus 1/3 of sine 3/0 plus 3 cos 1/3 of 0 plus 1, close the bracket. If you take your time when entering this stuff into the calculator on radians mode, you'll get 0.527 for this bracket minus 0.7057 for that bracket, with the final answer of 0.047.